Hello everyone, in this video we are going to discuss about the conversion of regular expression to DFA. Before explaining the conversion of regular expression to DFA, let me explain you the E-closure first. So E-closure means set of states reachable from Q through epsilon moves including the state itself. So why we must include the state itself means because like any closure should contain the state itself, because it is the current state and also it did not need any input to reach itself. So to remain in the same state, none of the input symbol is actually needed. So always when you find the E-closure for any state, always you have to include the state itself and then only you need to identify other possible states also through epsilon moves. For example, we will take this example epsilon NFA diagram. So there are totally 7 states are there. We are just going to identify the E-closure for each and every state now. So first, E-closure for the state 1. So always we have to include the state itself. The current state also you are supposed to include. Yes, we have included 1. Then again from 1 to, with the help of epsilon it is going to the state 2. Yeah, with the help of epsilon it is going to the state 2. Then again with the help of epsilon it is going to the state 4 also. Then again with the help from 2 again it is going to the state 3 also. Okay, I will write it again. Fine. The state itself always you are supposed to include. 1 with epsilon it is going to the state 2. Then again 2 with epsilon it is going to the state 3. Then again 3 with epsilon it is going to the state 6. Then again from 6 there is no epsilon transition available, so we can stop till here. Then again from 1 another epsilon move is also possible, that is to 4. Then again from 4 there is no epsilon moves possible from the state 4, we can stop till here. Then again epsilon closure for the state 2. So always you have to include the state itself and also from the current state what are the epsilon moves possible we have to write. So from the state 2 with the help of epsilon it is going to the state 3. So include the state 3. Then again from the state 3 with epsilon it is going to the state 6. Yeah, the state 6. Then again from the state 6 there is no epsilon transition available, so you can close the set. Then again epsilon closure for the state 3. From the state 3 with the help of epsilon it is going to the state 6. So always you have to include the state itself and then from the state 3 it is going to the state 6. Then after 6 there is no epsilon move available. So we are closing it. Then again epsilon closure for the state 4. From the state 4 there is no epsilon transition available, so only 4. Then again for epsilon closure for the state 5, the state itself and then 5 with the help of epsilon it is going to the state 7. Then again from the state 7 there is no epsilon transition available, so we are closing it. Then again epsilon closure for the state 6. There is no epsilon transition available from the state 6, so only 6 we are writing inside the set. Then again for 7 also from the state 7 there is no epsilon transition available, so only 7 is going to remain in the set, right? This is how we are supposed to calculate we are supposed to identify the epsilon closure for each and every state. Now we will take one example under regular expression to DFA. So first, either you can start from the regular expression or else from the epsilon NFA also it can be started, and then the corresponding DFA model can be constructed for the NFA diagrams, or sorry epsilon NFA diagram or the regular expression. So if this is the regular expression, the initial thing is we are supposed to construct the epsilon NFA first. So this is the regular expression. For this regular expression we have constructed the epsilon NFA diagram. So from the epsilon NFA diagram only the DFA can be constructed. So the initial step is we are supposed to identify the E-closure for all the states. From 0 till 10 we are supposed to identify the E-closure, right? If you take 0, E-closure for 0, include the state 0. 0 with epsilon it is going to the state 1. Yes, I have written the state 1. Then again from 1 with epsilon it is going to the state 2. Yes, I have written the state 2. Then again with the 1 it is going to the state 4. Yes, I have written the state 4. Then again from 0 with epsilon, because our current state is 0, right? So from 0 it is going to the state 7 also. So I have included the state 7 also. So we have identified the E-closure for all the states now. Now we are just going to start from the E-closure for 0 step, right? So first we have identified first you take the e-closure values for 0, since our the state 0 is going to be the initial state, we are just going to take the e-closure for 0 first. So e-closure for 0, we are getting all these possible states actually. So we just mark it as the state A, right? Now when you check, there are only two possible input symbols, that is A and B. So we have made a transition only with the help of the input symbol A, B as well as epsilon. So only two main input symbols are actually there, right? So you create one transition table, because we are just going to generate a transition table for DFA first, and then only we are just going to frame the construct the model. There are two input symbols possible, right? So what are all the states, how many states are going to be there, we are just going to compute now only. We are just going to start now only. It's fine. So you take the initial state, epsilon closure for the initial state first, and you mark that as the state A, right? Now you take the equation A, fine. There are two possible input symbols are there. You write A here. You have a state A now. You are just going to mark your initial state as, you are just going to rename your initial state as A. Now A with input symbol A, to which state it is going to go, then again A with input symbol B, to which state it is going to go, we are just going to identify now. For identifying that only, we are just going to consider this initial state. So from from our A state, these are all the states included actually. So what we are going to do means, we are just going to make a DFA transition from, these are the possible states inside the set from the equation A. So A, the equation A with input symbol A, the resultant states are 0 with A, there is no input, there is no transition actually possible. Then again 1 with A, from the diagram there is no 1 with input symbol A transition available. Then again from the state 2, yes, we have A transition. So from the state 2, with the help of input symbol A, it is going to the state 3. Then again from the state 4, there is no transition available under the input symbol A. Then again from the state 7, yes, we have A transition. From the state 7, with the help of the input symbol A, it is going to the state 8, right? We are getting the resultant states 3 and the 8, right? Now you take E closure for 3 and 8, right? So E closure for 3 and 8 we are just going to take, right? So you are just going to combine E closure of 3 as well as E closure of 8. These two you are just going to combine. So when you combine E closure of 3 and E closure of 8, 1, 2, 3, 4, 6 and 7 and 8 will be there in the set. Now from the state A, with the input symbol A, it is going to this state. You just compare these two sets, whether these two sets are equal or not. If it is equal, again you are just going to name it as A. Since these two are different, we have named it as A, you are just going to name this as B. It means what? From the state A, with the input symbol A, it is going to the state B, right? Then again from the state A, with input symbol B, we are just going to check. With the input symbol B, we are just going to check. So 0 with input symbol B, no transition available. 1 with input symbol B, no transition available. 2 with input symbol B, no transition available. 4 with input symbol B, yes, one transition is available, that is 5. Then again 7 with input symbol B, no transition available. So you can close it, right? Now the next step is, you identify the possible transition first, and then you identify the E closure for the resultant states. Fine, since there is only one state available in the set, calculate the E closure, identify the E closure for the state 5. Yes, we have already identified the E closure for the state 5. So what are all the states available under the E closure of state 5? 1, 2, 4, 5, 6 and 7. Fine. You compare this set with these two available sets. So when you compare this with these two, this is again different only. So you can name it as C, right? So A with input symbol A, it is going to the state B. A with input symbol B, it is going to the state C. So when you check B and C, according to DFA, the constraint is what? Each and every state must hold the transition under each and every symbol exactly once. For example, there are two input symbols available here, A and B. It means what? The resultant DFA diagram, the DFA model must have A transition as well as B transition exactly once in each and every state. That is the condition, right? DFA condition. So all the transitions exactly once from each and every state must be available. That is the main condition which is coming under DFA. So when you check these two states are a new state, right? So you are supposed to identify the A transition as well as B transition from the state B as well as from the state C, right? Now we have taken A with A we have identified, A with B also we have identified, right? Now we are just going to take the equation B. From B with input symbol A and input symbol B we are just going to identify, right? Now take B. B with A and B with B we are just going to identify. So the DFA transition of, so here what is B? What are all the states available in B here? 1, 2, 3, 4, 6, 7, 8, right? So 1, 2, 3, 4, 6, 7, 8 with input symbol A, right? So 1 with A, there is no transition available from the state 1 to A, right? There is no transition available from the state 1 with A. So then again from 2 also there is no transition available. Then again from the state 3, from the state 2, yes, this transition is available. If you check the diagram, 1 with input symbol A, no transition available. 2 with input symbol A, yes, it is available. So we need to include the set, we need to include the state 3 inside the set, right? So include the state 3 inside the set. Then again 4 with A, there is no input symbol, there is no transition available. 6 with A, no transition available. 7 with A, yes, the transition is available. 7 with input symbol A, it is going to the state 8. So you include the set 8. Include this set 8. Then again 8 with input symbol A, it is not available. So only 3 and 8 will be there inside the set. Now the next step is identify the E-closure for 3 and 8. So E-closure of 3 and E-closure of 8 we are just going to combine. So after combining, the resultant states are, what are the states will be there inside the set, means 1, 2, 3, 4, 6, 7 and 8, right? Now these are the resultant states, right? So we are just going to compare this set along with A and B. So previously we made 3 equations, 3 states, 3 new states A, B and C. We are just going to combine this along with A, B and C, whether it is same or different, we are just going to compare. So when you compare, yes, it is same like the B set, right? So we are just going to mark it as B. It means what? B, from the state B with input symbol A, it is reaching the state B. So we can fill the transition table now. B with input symbol A, it is going to the state B, right? Now again B with input symbol B, we are just going to check, right? 3, 4, 6, 7, 8, comma, the input symbol B. Now we are just going to check 1 with B, no transition possible, right? 1 with B, no transition possible. 2 with input symbol B, no transition possible. Then again 3 with input symbol B, no transition possible. 4 with input symbol B, yes, we have transition. 4 with input symbol B, it is going to 5. So include 5 inside the set. Then again 7 with input symbol B, no transition. 8 with input symbol B, yes, it is possible. From 8 to 9 with input symbol B, it is possible, right? So we are just going to include 9 also. The next step is find epsilon closure for the state 5 and 9. We are just going to combine 5 and 9 E closure values, right? So when you combine, we will be getting 1, 2, 4, 5, 6, 7 and 9, right? We are just going to compare this set along with the previous 3 sets A, B, C. So when you compare, this is not the same, this is actually different. So already we have a state A, B and C, and so we are just going to name this as the state D. So B with input symbol A, it is going to the state B. Then B with input symbol B, it is going to the state D. So you can fill here in the transition table, right? Next, B it is over, right? So B it is over. Now we are just going to take C now. Right? So DFA transition off. So what are all the sets available? What are all the states available in C set? We are just going to check 1, 2, 4, 5, 6 and 7, right? So take 1, 2, 4, 5, 6 and 7 with input symbol A as well as input symbol B. We are just going to identify, right? So 1 with A, no transition possible. 2 with A, yes it is possible, it is going to the state 3. Then again 5 with A, no possible. 6 with A also there is no transition available. 7 with A, yes it is possible. So from the 7 with input symbol A, it is going to the state 8, right? Take E closure for 3 and 8. As usual, you combine E closure of 3 as well as E closure of 8, right? So if you combine, you will be getting 1, 2, 3, 4, 6, 7 and 8. So when you compare this set along with A, B, C and D, because previously we made four different states, right? So we are just going to compare this state along with A, B, C and D. So when you compare, this and B is actually same. So we are just going to name it as B, right? So C with input symbol A, it is going to the state B. C with input symbol B, where it is going, we are just going to check. 1, 2, 4, 5, 6, 7 with input symbol B. So 1 with B, it is not possible. 2 with B, no transition. Then again 4 with input symbol B, yes it is possible, it is going to the state 5. Then again 5 with the input symbol B, no transition available. 6 with input symbol B, no transition available. 7 with B also, no transition available. So only 5 is going to be there inside the set. The next step is identify E closure for the state 5. So for the state 5, the E closure value is 1, 2, 4, 5, 6 and 7, right? Now you are just going to compare this set along with the previous sets. When you compare, I think this set and the set C is equal. So we can name it as state C. It means what? C with input symbol A, it is going to the state B. C with input symbol B, it is going to the state C. So you can fill the transition table here. C with input symbol A, it is going to the state B. C with input symbol B, it is going to the state C. Now when you check from okay, if you start from the state A, with A it is going to B, with B it is going to the state C. Since B and C are the new states, we are making a transition for B and C. For B, it is B with A, it is B. B with B, it is going to the state D. So when you compare B and D, D is actually a new state. So you need to check for D now. For A with A with B have checked. B with A, B with B we have checked. C with A and C with B also checked. D with A and D with B we are just going to identify now, right? So take D. So DFA transition of inside D, what are all the states are there? D set 1, 2, 4, 5, 6, 7, 9, right? With input symbol A, we are just going to identify. So 1 with A, no possible. 2 with A, yes it is possible, it is going to the state 3. With 4, 5, 6 and all, no transition with A possible. From the state 7, yes A transition is possible, it is going to the state 8. Then again 9 with A, no possible, so we are just going to close this set. Identify E closure for 3 and 8. So you combine E closure of 3 value as well as E closure of 8 value. E closure of 3 and E closure of 8 you combine. After combining it, we will be getting 1, 2, 3, 4, 6, 7 and 8. You compare this set along with the previous sets, it is looking same like a B set. So we are naming it as a B state. Then again D with input symbol B, right? 1, 2, 4, 5, 6, 7 and 9 with input symbol B, right? So then again 1 with B, no possible. 2 with B, no possibility. 4 with B, yes it is possible. 4 with B, it is going to the state 5. Then again 6 with B, no possible. 7 with B, no possible. 9 with B, yes it is possible, it is 10, right? Now you find the E closure for 5 and 10, right? So when you combine E closure of 5 as well as E closure of 10 values, you'll get 1, 2, 4, 5, 6, 7 and 10 in the resultant set. You compare this set along with the previous sets. When you compare, this looks different only. So we are just going to name it as the state E. It means D with input symbol A, it is going to the state B. D with input symbol B, it is going to the state E, right? So B and E. D with A, it is going to the state B. D with B, it is going to the state E. When you check B and E, B is the old state, already it is reachable. We have made the transition for B. But when you check E, E is the new state. So you are just going to make the transition newly for E now, right? So take E now. So E with A and E with B, we are just going to identify. So DFA transition of the set 1, 2, 4, 5, 6, 7 and 10, comma A. E with A, E with B, we are going to identify. So when you check 2 with A and 6 with A alone possible, so the resultant set is going to be 3 and 8. Identify E closure for 3 and 8. So we will get 1, 2, 3, 4, 6, 7 and 8 we will get. So when you check this set along with that, compare with this with all the previous sets, it looks similar to the state B, so we are naming it as B. Then again with input symbol B, E from the state E with input symbol B. So when you check the B transition is from 4 with input symbol B, it is possible. Then again 5 with B not possible, 6 with B also not possible, 7 with B also not possible, and 10 with B also not possible if you check the diagram, right? Only from 8 and from 4 only it is possible. Since there is only 4 alone there in the set, so only 4 with the B it is possible, it is going to the state 5. So you can close the set. E closure for the state 5 is 1, 2, 4, 5, 6 and 7. So when you check, it looks similar to the state C. When you compare all this, it looks similar to the state C. Next, so from the state E, it is going to the state A. From the state E with input symbol A, it is going to the state B. From the state E with input symbol B, it is going to the state C. So we can fill the transition table here. E with A, it is going to the state B. E with B, it is going to the state C. Now, when you check, there is no new state available over here actually inside the transition table. So we can stop our computation till here. Now we are just going to make the transition, we are just going to construct DFA diagram for this transition table. So this is going to be our final transition table for our DFA. A with A, it is going to the state B. A with B, it is going to the state C. B with A, it is going to the state B. B with B, it is going to the state D. C with A, it is going to the state B. C with B, C. Then again for D, D with A, B. D with B, E. E with A, B. E with B, C. Right? Now, this is the final transition table for constructing DFA. Now we will construct the DFA diagram for the above transition table, right? Now totally there are 5 states available, right? So you start from the state A, B, then C, D, then E. So totally there are 5 states. We are just going to make the transition from each and every state under all the input symbol A and B, symbols A and B, right? So A with A, it is going to the state B. Then again A with B, it is going to the state C. So A with input symbol B, it is going to the state C. B with A, it is remaining in the state B only. B with B, it is going to the state D, right? Then again C with A, it is going to the state B, right? C with A, it is going to the state B. C with B, it is going to the state C only. So make a self loop and write the input symbol. Then again D with A and D with B. D with A, it is going to the state B. D with B, D with input symbol B, it is going to the state E. Then again E with A, it is going to B. E with B, it is going to the state C. Right? This is the final DFA diagram for the regular expression A plus B the whole star ABB. Right? First you are supposed to generate Epsilon NFA diagram. After generating Epsilon NFA diagram, you are supposed to compute E closure for all the states. After computing E closure, you just name each and every set as a one single state. You just compare that state along with all other states. If it is same, you keep the same, you just name it as the same state name. If it is different, you need to allocate the different state name. Finally, until no new state is available, you need to keep on doing the computation, like compare, you need to keep on identifying the transition with the A input symbol as well as B input symbol, and finally when there is no new state available, you can stop doing the computation, and after that you can make the final DFA diagram for the transition table. This is how you are supposed to construct the DFA diagram for regular expression. Thank you.